In this video, we're going to answer the question, how does a photovoltaic panel work? Just to avoid any confusion, this is the type of panel that uses sunlight to create electricity. This is sometimes incorrectly referred to as a solar panel. A solar panel uses sunlight to heat water for a property. For the rest of this video, we'll be referring to the photovoltaic panel as a PV panel. So how does a PV panel use sunshine to generate electricity? Well, let's give the simple answer first, and then we'll take a closer look at the science behind it. The short answer is, tiny particles from sunlight hit tiny particles in the panel, giving them enough energy to break away more tiny particles that make electricity, and then those tiny particles that make up electricity build up on one side of the panel, and we can pass them to the other side of the panel through our electrical equipment. So that's the simple answer. Now let's dig a little deeper into this fascinating subject. To answer this question properly, we'll need to first of all understand what electricity is. Everything we see around us is made up of tiny particles called atoms. Atoms in turn are made up of smaller particles, so-called subatomic particles. These include protons and neutrons, which sit in the middle of the atom, or the nucleus. Protons are said to have a positive charge, and neutrons have a neutral charge. Around the outside of the atom are tiny particles called electrons. These electrons have a negative electrical charge. Where an atom has an equal number of electrons and protons, the negative and positive charges cancel each other out and leave the atom electrically neutral. Some atoms of materials like copper have what's called a free electron, and these electrons can easily be persuaded to move from atom to atom. When a whole bunch of these electrons flow in the same direction through a material, that is what we refer to as electricity. So what happens inside the PV panel? Well, the key to understanding this is to understand the structure of a PV panel. It's made up of two layers of crystal, and in some types of PV panel, you can see this crystalline structure on the surface from certain angles. The two layers of crystal are different from each other in one very important way. The crystals that make up these two layers are made from silicon, and when processed and refined, the atoms of pure silicon lock together via their electrons in a certain way that makes the material not very good at allowing electricity to flow through it. So one layer has a small amount of another element added to it, such as phosphorus. This material allows for a number of extra electrons to be available, which makes the material have a slightly negative charge. This is referred to as an N-type material. The second layer has a small amount of another element, such as boron, added to it. This causes the material to have a smaller number of electrons in its structure, leaving gaps where electrons want to sit. These gaps are referred to as holes. Because of the lack of electrons in the material, it now has a slightly positive charge and is referred to as a p-type material. Now, when these two layers are joined together in the manufacturing process, some of the extra electrons in the n-type material are drawn to the holes in the p-type material, and vice versa. But this process stops after a short while because a barrier of less conductive atoms has appeared where the layers join due to the electrons filling the holes. This barrier is incredibly thin, approximately 1 micrometer wide, or in other words, 1/1000th of a millimeter, and is referred to as a depletion zone. Now the material has what's called a p-n boundary, and no electrons will cross that boundary without some external influence. When the PV panel is placed in the sunlight, something extraordinary happens. Light is made up of tiny particles called photons, which behave in very strange ways, sometimes acting as a particle and sometimes acting as a wave. When the photons from the sun hit the PV panel, they can transfer enough energy into the atoms in the depletion layer, causing some electrons to separate and migrate into the n-type layer, and effectively holes to transfer into the p-type layer. This causes a difference in electrical charge between the two layers, and the electrons and holes will want to recombine, but can't cross the depletion zone at the p-n boundary. However, if we give the electrons a route back another way, say via a copper conductor, the electrons will then flow through the conductor back to where they started. So we have electrons flowing through a conductor, which is what we defined earlier as electricity. And if we interrupt that wire with, say, an electric lamp, we get light. Or if we interrupt it with a toaster, we get toast, and so on. And that is how a photovoltaic panel works. As we said at the outset, tiny particles from sunlight hit tiny particles that make up electricity in the panel, and those tiny particles that make up electricity then build up on one side of the panel, and we can pass them to the other side of the panel through our electrical equipment. Clever stuff. This is just one example of how we can use renewable sources of electricity to power our way of life. For more information on other ways to use renewable and efficient sources of energy, please like, subscribe, and hit the bell to turn on your notifications, and check out our other videos here on eFIXX Energy. And as always, we'd like to hear from you. What are your thoughts on energy efficiency, renewables, and sustainable living? Have you had solar panels installed on your property? Has it made a difference to your outlook and finances? Please leave your thoughts and questions in the comments section below. And as always, thank you very much for watching.